Hi everyone, I'm going to present my implementation for the traffic assignment. So in this video, we will first start off by looking at how to load the data, then look at the model itself, and lastly, we briefly touch on the model performance. So let's take a look at how I loaded the data. This was quite straightforward. I simply use OS modules lister method to list all category folder names in the dataset, and then loop through each of these category folder, again using OS lister to get all image names, and then reading the images using CV2 packages IMRI. After reading the dataset, I plotted one image of each category just to better understand the dataset. So here you see the label and the image. Some observations we can make here are that there are quite a few speed limit signs, such as 20, 30, 100, and so on. There are a few of the symbol-based signs, such as the truck, wildlife, etc. We also have direction signs, which are in different colors. Another observation is the resolution of the image is quite important. We need to have a high enough resolution to capture the details. Now let's take a look at the model itself. That's the most interesting part of the assignment. So the first layer is the input layer, and I used the RGB channels and used a pixel size of 40 by 40. It's important to use the color images because the traffic symbols have colors which distinguish them. And also having a good enough resolution is important so we can accurately represent the symbols, the shapes, and the numbers. The next layer is the filter layer. I'm using one filter layer with 80 filters, experimenting with the kernel size 3 by 3 and 5 by 5. 3 by 3 just marginally outperformed 5 by 5, so I stuck with that. With the activation function, I realized it's very important to use activation in the filter layer. And for this specific configuration, softmax did slightly better than ReLU. The next layer I'm using is the pooling, just to reduce the dimensionality. And then after this, we go to the normal neural network, flattening the layer, and I'm using two hidden layers with about 100 neurons each, activation being ReLU. And we have to note that I'm using a dropout frequency of 0.2. One lesson I learned here is not to crank this too high. Then the model has fitting issues. The output layer has 40 neurons, each representing a class, and using softmax activation. I trained for 20 epochs and then got a training accuracy of about 96% and test accuracy of 97%. So we do see that this generalizes quite well. Let's now take a look at the model in action. As you can see, I'm training for 20 epochs and we are witnessing the last epoch. The accuracy is converging to about 97%. Now the model is being trained for 20 epochs and we have an accuracy of 97%. We've seen a test results, which is again about 97%. This is showing that the model has converged and generalizing well. So the model worked well, but what about the misclassified images? What are they like? Here I plotted a few of these misclassified images. What we already see is that the model is somehow mixing up these speed limit signs. So we need to maybe improve the resolution or train a better model to capture these numbers. Then we also see that the data set has quite a few of these very poor images which may be almost impossible to classify.